You have the classifications of ordinary differential equations, and that is testing for whether the equation is homogeneous or not homogeneous. I want to do a quick recap on the linearity, where we agreed on certain rules to be considered. These are the rules. We also use the word unknown and its derivatives. I want to state that the unknown here, it refers to the dependent variable in the equation, so you take note of that. Now let's look at the homogeneous aspect of the equation. It says the differential equation is homogeneous if there is no non-differential term in the equation, or when the equation is also set to 0, it is homogeneous. Now I don't want to dwell on the setting to 0 because sometimes it might get tricky. I want to dwell here when there is no non-differential term. The non-differential term means that I want to have all my terms in the dependent variable. It means that if there exists any independent variable in my equation, it becomes not or non-homogeneous. This will be very cool than just dwelling on when it is set to 0. Okay, so I want to have all the equations written in the dependent form, or with respect to the dependent variable. Other than that, if I have any term of the independent variable, then I say that the equation is non-homogeneous. So I'll take the same examples we've gone through and then look at the homogeneous test. The first example, we've already done these classifications. Is it homogeneous or not homogeneous? Realize that I have my dependent variable here, y, I have y here. There's one more term, this guy. It is not with respect to y. It's also not the independent variable, it's a constant. And so we can say that this equation is not homogeneous. Someone will say, well, madam, I could make it this way, plus 3y minus 6 and set to 0. No. If you set to 0, you might assume that this would hold. Let me rather use the arrow here. But because of the negative 6, it makes it not homogeneous. Alright. I hope that was well explained. So it means this is not non-homogeneous, non-homo. I'll use a shorthand here. Example 2. Let's go through. There's a term of the dependent, there's a term of the dependent, there's a term of the dependent, and it's also set to 0. So straight away, this is homogeneous. The example 3, I have the dependent. This term here makes it non-homogeneous. That is the non-differentiable term, or the term with the independent variable. Okay, if you again take it to the the left hand side and then say is equal to 0, this is a non-differential term. So don't dwell on just the setting of 0, but look out for the non-differential term, or the term that has the independent variable alone. It means your equation is not homogeneous. So let me clean this up. The example 4, is it homogeneous? I have the terms of the dependent here, terms of dependent set to 0. Okay. Example 5, the terms of y. Let me re-emphasize here. I'm using y as my dependent variable. So in the case where you don't see y, you don't see x, you must be able to tell your dependent variable and then your independent variable to make sure you can tell whether your equation is homogeneous or not. Okay, so you take note of that for me, please. So clearly we can say this is what homogeneous equation. So we have 3 homogeneous, 2 non-homogeneous equation. Simply checking for the non-differential term. I have a special example here. Let's look at the classification. It is an ODE. What do you think the order would be? The highest derivative. This is order 1, this is order 3. So the highest derivative is 3. What is the degree here? the degree is the index of the highest derivative, and that is 2. Is it linear? This is where the game starts. Is it linear? Is it linear? Someone will say it is linear. Why? If you can give a reason, good. If not, you should know. This is non-linear. This has a degree of 1, but this term here has a degree of 2. We can even see it from here. And so straight away, this refuses to be a linear equation because the first rule is violated. It says all the terms must be of degree 1. The first term has degree 2, hence non-linear. Okay. Now, is it homogeneous? Someone would say, well, madam, I see it equal to 0, and so homogeneous. No. You must search for the non-differential term, which we can clearly see it is here. Minus 6x. That is the independent variable expression. And so this also is non-homogeneous. These things can be a bit confusing, but if you take your time and understand, you wouldn't get any of the answers wrong. Alright, let me end by saying that if you could see how I've done my table, I can read this at a go. So let me take the first example. It was the forgive me for the scrolling up and down, dy dx plus 3y, dy dx plus 3y equal to 6. If you're asked to classify this, you have to check for the type. So it is ODE. You have to check for the order. It is order 1. You have to check for the degree. It is degree 1. You have to check for linearity. We say it is linear. You have to check for homogeneity and realize this is non-homogeneous. So that's how you would say this equation. This differential equation is a first order ordinary differential equation. No, let me just say it well. It is a first order linear non-homogeneous ODE. Yeah, that's how we write them. The order comes first. Forget about the degree here. The order comes linear, homogeneous, then the type. That is how you say the entire thing. Let me clean here. So we mostly, if I want to write the entire classification, I take the order first, followed by whether it is linear or non-linear, followed by whether it's homogeneous or not, then I go by the type. So I could have like a second order non-linear homogeneous ODE. Okay, because I'm using the same notes, I still have my writings here, so I'll clear them. I could say this is a first order linear non-homogeneous ODE. This is how you do your classification at a go, or something PD. We didn't go through the examples on PD, but we'll look at that in our subsequent sessions. But for now, everything will be under the ODE. So if I want to take the very last one here, then it means that this is let me clean what I have written here and then do the writings there. Let me use green. This is a third order non-linear non-homogeneous ordinary differential equation. You see the format. So this is how I'll do my classifications. After writing out the single versions of it, I have to join them in this form. So if I move to this example here, this is a second order non-linear non-homogeneous ODE. If I move to this line, it is a second order linear homogeneous ODE, and so on and so forth. So this is how the classifications is done. Please take your time, go through the videos on the classifications one after the other, take examples from textbooks, and then see how you can classify differential equations. The next lecture videos will be on solutions to differential equations. Stay tuned.